So let's practice an integration in non-rectangular region. Calculate the area of the triangle shown by using double integrals. Okay, so we want to integrate now inside this triangle. This will be our area A. Okay, and we are asked to calculate the area, which means that the area will be equal to the double integral inside of this region A times the differential of area. Okay, that will be what we have to do. So this will be the double integral in the area A with respect to x and with respect to y. Okay, so the question obviously now is, how do we determine the limits for this case of a triangle? And as I showed you, we have two ways of doing it. We can first integrate along y and then along x, or we can first integrate along x and then along y. So let's do it in both ways. I have space for both so that you see that they coincide, and also that you see that sometimes one method is simpler than the other method. So the first thing we need to do is to find out the equations for these lines, this line, and this line. We need to find the equations in terms, y as a function of x, right? So what is the equation for this line here? So the equation for this line here is y equals 0. Okay, that one is very easy. So that is what I mean is this line here. That's the line y equals 0. Now let's think about this line here. Okay, what is the equation of this line? There are many ways to find out, but my preferred way is to say that this is the equation of a straight line. So you can always write it as y equals m times x plus c, where m is the slope and c is the intercept. Okay, so what is the slope of this line? The slope is defined as the change in x, the change in y divided by the change in x. So the slope is -1. So y equals -1x. And then plus the intercept. What is the intercept of this line with the y-axis? It intercepts the y-axis at y equals 1. Therefore the intercept is 1. Okay, so basically this is the equation y equals 1 minus x. Okay, now what about this line here? So again we use the trick y equals mx plus c. So what is the slope of this line? The slope is 1, right? Because this is a 45-degree angle, so the slope is 1. And what is the intercept of this line with the y-axis? It intercepts the y-axis at y equals 1. Therefore this line is given by x plus 1. Okay, so that is my equation for the top line. So now we have equations for all of the lines that bound this region of integration. So therefore we can now calculate the integral. So the area A is equal to, now since the limits are changing, so we are going to integrate first along y. Okay, so if we integrate first along y, we need to imagine green arrows moving along the y direction. And we need to consider when does this green arrow enter the region of integration and when does it exit. And the first thing that we notice is that the limits of integration will be different depending on whether x is in this region here or whether x is in this region here, because then the upper limit will be a different function, right? So therefore we have to split this integral into two. Okay, so this is what we are doing. We are splitting this integral into two. We are first integrating along y and then along x, but we are doing it twice. The integrand is 1. Okay, I explicitly wrote it. Imagine that there is a 1 over there because we are integrating the differential of area, which is dx dy. So there is explicitly there is a 1 there. So this is 1 dy as the inner integral, and the outer integral is dx. So let's write the limits. Okay, so this first integral refers to this area here. So as I said, we start by integrating along y, so we picture this line progressing along the y direction. So when do we enter the region? We enter the region at y equals 0. And when do we exit the region? we exit the region at y equals x plus 1. So that's exactly what we write here, x plus 1. So normally we don't have to write y equals 0, we just write 0. But of course this is the value of y as the lower limit and the value of y as the upper limit. So between 0 and x plus 1. And once we have done the inner integral, we have to project this triangle into the remaining variable, which will be x. So we project this triangle onto the x-axis. So this means that the limits for the x-axis will be between -1 and 0. Okay? So that's the first integral. Now the second part, which is this area here. So we are first integrating along y. So we draw this vertical line and we look at where does it enter the region of integration and when does it exit the region of integration. So it enters the region of integration at y equals 0 and it exits the region of integration at y equals 1 minus x. So that is what we write over there. And then once we do the inner integral, we project the area into the remaining variable, which is x. So we project that area into x. So we have to now integrate between 0 and 1. That will be the limits for the outer integral. Okay? So let's do this calculation. So let's see how it works when we have variables inside of the limits. So we keep the outer integral as is. So what is the integral of 1 with respect to y? So the integral of 1 with respect to y is y. But y evaluated between y equals 0 and y equals x plus 1. Now dx. Okay? Plus the other integral. So let's leave the other integral for now. Let me focus on the first one. So this is going to be the integral between -1 and 0 of, so now I have to substitute y equals x plus 1 minus y equals 0. So we get x plus 1 dx plus something else. So what is the integral of x plus 1 with respect to x? So the integral of x plus 1 with respect to x is 1/2 x squared plus x, evaluated between x equals -1 and x equals 0. Okay? So the result of this is what? This is 0 plus 0 minus 1/2 and then plus, so minus x with x equals -1, so this is plus 1. So this is the result of this first part. But we still need to add the second integral, which I left here. Okay? So let's solve that second integral. So we leave the outer integral as it is, but we solve the inner integral. So what's the integral of 1 with respect to y? It's y. And the limits are between y equals 0 and y equals 1 minus x dx. So now we substitute the two limits. So we get that this will be 1 minus x minus 0 dx. So now we are left with a function of x. Okay, so far that is exactly what I promised, that when you do the inner integral along y, the result is a function of x. Yes? So as promised, we are getting a function of x that we can now integrate along x. So this will be, what is the integral of 1 minus x? It's x minus x squared over 2. And this is evaluated between x equals 0 and x equals 1. So the result is 1 minus 1/2. Okay? So the total integral is 1 minus 1/2 plus 1 minus 1/2, which is equal to 1. And that is indeed the area of this triangle. Okay? The area of this triangle is 1. Now, let's choose the other way of doing it. Let's choose to integrate first along x. And you will immediately see that this is easier because we don't have to split the region of integration into two. Because now the lower limit, so what will be the lower and upper limits? So if we're integrating along x, we imagine you draw a line in the x direction, and then you think about the lower limit is wherever we enter the region of integration, and the upper limit is wherever we leave the region of integration. Okay? So remember, this was a function y equals 1 minus x, and this was a function y equals 1 plus x. So we now know the equation for the lower limit and the equation for the upper limit. So let's write it down. The area is the integral of 1 dx, because we are integrating first along x, and then dy on the outside. Yeah. So as I said, to figure out the limits of the inner integral, we have drawn this line. We come in on y equals 1 plus x. So we write 1 plus x here. This is wrong, but let me explain why. What would be the upper limit? The upper limit would be this line here, which is 1 minus x. So we write 1 minus x here. And then the limits along y would be, you project the triangle into the remaining variable, which is y. So you project it into the y-axis, and therefore the limits would be between 0 and 1. But why is this wrong? And let me be clear that this is wrong. Because if you try doing this integral, you are going to end up with x evaluated between 1 plus x and 1 minus x. So you are going to end up with a function of x, right? Actually, it's going to be minus 2x. So then you didn't get rid of the x. And now you cannot integrate minus 2x with respect to y. You would end up with an area that depends on x, which is completely wrong. It doesn't make any sense. And the reason for this is that in the limits for the inner integral, okay, I have copied here the integral, but without the inner limits. So these inner limits correspond to the lower limit of variable x and the upper limit of variable x. So obviously the lower limit of x is not 1 plus x. Okay, so what is the lower limit for x? So if y equals 1 plus x, we need to solve the value of x, that is the lower limit. So x equals y minus 1, right? We just bring this 1 as a negative 1 on the other side. So x equals y minus 1. That is the lower limit for x. X equals y minus 1. And what is the upper limit? So the upper limit, we need to solve for x in this expression. So the upper limit will be x equals 1 minus y. Yeah? So that is the upper limit for x, 1 minus y. Okay, and now this makes sense because this is the value of x in the lower limit and this is the value of x in the upper limit. So now we solve this equation. So this is the integral between 0 and 1 of the integral of 1 with respect to x, which is equal to x, evaluated between x equals y minus 1 and x equals 1 minus y. So if we calculate that, that is equal to 1 minus y minus y minus 1 dy, which is equal to the integral between 0 and 1 of 1 minus minus 1 is 2 minus y minus minus 2y dy, which is equal to the integral of 2 minus 2y with respect to y. So that is 2y minus y squared between y equals 0 and y equals 1. So this is equal to 2 minus 1 minus 0, which is 1, which is equal to the area of this triangle. Okay? So you can see that both methods gave you the area of the triangle, but this method was considerably shorter. Okay? Integrating first along x turned out to be a bit shorter than integrating first along y. Okay? So always choose wisely the order of integration. How do you know? How can you figure out which one is going to be shorter? That comes from experience. But here you could clearly see that if you integrated first along y, you would have to use 2 regions of integration, right? Okay, great. See you in the next video.